Hey, what's up, everybody? So, I wanted to show you guys in live time the infinite Fibonacci journey, basically the tool that I just created. I think that it's absolutely amazing. And so, the best way to do this is kind of show you guys live. All right, so we're going to go ahead and check this out. As you can see right here, there's a little bit of information here talking about the Fibonacci. The Fibonacci sequence is a cosmic symphony where each number is the sum of the two preceding ones. All right, so 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, 5 plus 8 is 13, 8 plus 13 is 21, and it keeps growing and growing and growing. All right, it can just get bigger and bigger and bigger. Right, so the number one thing that we want to focus on is going to be the fact that time is not arbitrary. All right, it is not arbitrary. 60 seconds, 60 minutes, and 24 hours a day is not arbitrary. Anything that comes after that can be changed, can do whatever you want. But these numbers right here, these are not arbitrary. All right, so I'm going to go ahead and show you that in live time. But to do that, I got to show you what this tool can do. All right, so we're going to scroll down just a little bit. I'm going to go ahead and hit start. And as you can see right here, we've got our Fibonacci sequence. So all it's doing is just adding the next one. 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, so on and so forth. And as you can see, it just gets bigger and bigger. 21 plus 34 is 55, 55 plus 89 is 144, 89 plus 144 is 233, and it just keeps going and going and going. All right, so we're going to go ahead and we're going to stop at the 24th number. So you can see here that if you were to take the digital root, if you don't know what a digital root is, it's literally just adding up any numbers until you have one singular number. All right. So if the number has, the number is 13, it's just 1 plus 3, and that would give you a 4. So 4 is the digital root of 13. If it's 55, 5 plus 5 is 10, but that's still two numbers or two digits. So 1 plus 0 is going to be 1. And so 1 would it be the digital root of 55. So no matter how big the number gets, you can always just keep adding and adding and adding until you have one number left. And that one number is called the digital root. Okay. So when we take the first 12 digital roots from the first 12 of the Fibonacci, we get 1, 1, 2, 3, 5, 8, 4, 3, 7, 1, 8, 9. When we take the next 12, in other words, going to 24, we get 8, 8, 7, 6, 4, 1, 5, 6, 2, 8, 1, 9. So the first thing that you're going to notice is that if I were to actually add these up, 1 plus 8 is 9, 1 plus 8 is 9, 2 and 7 is 9, 3 and 6 is 9, 5 and 4 is 9, 8 and 1 is 9, 4 and 5 is 9, 3 and 6 is 9, 7 and 2 is 9, 1 and 8, 8 and 1, and 9 and 9, which is 18, and 1 plus 8 is 9. So you have this perfect balance every 24 digits that give you 9 all the way across the board. Okay. Now, that's not the only pattern that's found in here because there's also a pattern that's even easier for you guys to see now, which is called the 60-digit last number pattern. So basically, every single one of these numbers has a last digit. So after 8, you have 13. That will be a 3. It's just the last one. All right. So it's the very end. All you got to do is put your mouse right here and you're at the number. And so as it continues going, so I'm going to go ahead and let it continue going, you're going to see this pattern over here. Okay, so this right here is the digital root pattern, and it's just going to repeat to infinity 1, 1, 2, 3, 5, 8, and then the next 12. And then notice it's going to continue doing the exact same one right here, and it'll keep doing this to infinity. Over here, you have a 60-digit repeat pattern. So basically, as you can see, it's going through its pattern through the last digit, right? It's every 15. So I'm stopping at 15 because every 15th number is going to end in a 0 no matter what, which is going to give you that north, south, east, and west. But as you can see, once it finishes this, it's going to start all over again. 1, 1, 2, 3. And that's not guessing. If you go over here, we're going to go ahead and stop real quick. We go over here, we've got 1, 1, 2, 3, 5, 8, 3, the exact same numbers. So no matter how massive this number right here gets, and we're going to allow it to run for a little bit, no matter how massive this one over here gets, as you can see, it's just going to keep repeating the same thing over and over and over and over to infinity. And why is this so important? Right? The reason this is so important is because we say that time is arbitrary. But what if it isn't arbitrary? What if the whole entire point is that for you to have a pattern, you have to have two? So the very first set of 60 digits, right? So again, this is repeating at this point. The very first set of 60 digits right here is 60 seconds. And then once you have 60 seconds, you have the very first minute, which would be the second cycle. And once you have the very first minute, then you jump over here and you end up with 24 hours in a day. So there is no question whatsoever. We have 60 seconds in a minute, and we have 60 minutes in an hour, and we have 24 hours in a day. And that's all found just by dealing with Fibonacci. Okay. So notice this number is astronomically large at this point in time, and it's just repeating the exact same patterns over and over. You can check it live, you can go through it, and you will notice that nothing changes in any way, shape, or form. This will go on to infinity. This will go on to infinity as long as this number keeps counting. So if this number right here at the very, very beginning, so I'm gonna go ahead and stop, the very, very beginning is actually the start of time. So when time begun, it was 1, 1, then it was 1, 1, 2, 3, 5, 8, and it keeps counting. If this has been running since the beginning of time, we have no idea where we are in this. Because as you can see, if I just allow it to keep going, it just gets huge. And if you don't think that that's huge, let me show you an example here. 72, so we have 1, 2, 3, so thousand, million, billion, trillion. 72 trillion, 723 billion, 460 million, 248,141 is only the 68th place in Fibonacci. All right. It just keeps growing and growing and growing. And yet, if we were to reduce all these numbers down, right, we would end up with just one of these numbers right here. And if we were to take the last digit, as you can see, 7741, where are we at? Find our seven. Let's see here. We're 77415617, right? So you got 77415617. There's no guessing, there's no changing the numbers. It literally, you just take the last digit and it will continue repeating this pattern to infinity. So when someone tells you that the Romans made up the second, that's not correct at all. This goes all the way back to the Babylonian era. That's why they focus so much on those 60 digits. That's why they called it 60-based math. But it's not 60-based math. It's Fibonacci. And if you actually take this, you would see that this pattern repeats forever. It'll never stop. And this one over here repeats forever. So with that understanding, we can take 60 seconds in a minute. We can take 60 minutes in an hour. We can take 24 hours in a day. And now you have time. All right. I wanted to do a video real quick to show you guys this in live time. I wanted to show you how it actually works. And I want to show you that you can go ahead and play with this. If you just go to 9 Vibes Universal, click on the cosmic clock, go down to the Fibonacci counter. It is literally going to pull this up. I'm in it right now. So if I want to clear it, starts everything all over again. As you saw, you can stop at any point in time, and then you can start it at any point in time. And that way you can start doing your own experiments and seeing what numbers stand out and what numbers don't for you. All right. Get your 9 vibes aligned.